Welcome to my channel. Today we are going to discuss about the Fourier transform multiple choice question and answer. Okay, so from the previous in the previous video we discussed Fourier series MCQ questions. So now we are going to see about the MCQ questions from Fourier transform. Okay, so this is from the second unit. So first question you see, which of the following is the analysis equation of Fourier transform? So what is mean by analysis equation? So analysis equation means the equation in order to find the Fourier transform of the given time domain signal x of t. It is called as a Fourier transform analysis equation. So which equation? So the Fourier equation is given. Which one is a correct Fourier transform equation? The first you see capital X of j omega equal to integration x of t e power minus j omega t dt. It's a correct thing. So in the second thing x of j omega equal to integration x of t e power plus j omega t. It is not a correct. So e power minus j omega t dt. This first is a correct answer. Okay, with respect to t, we have to integrate our time domain signal with the multiplication of e power minus j omega t. This is the analysis equation. Okay. Then the second one, which of the following is the synthesis equation of Fourier transform? Okay. Synthesis. What is mean by synthesis equation? Means the inverse Fourier transform equation is called a synthesis equation. That is, in order to convert the frequency domain back to time domain, that is called as a synthesis equation. So which equation is a synthesis equation? So which one is the inverse Fourier transform? You see, x of t equal to 1 by 2 pi integration x of j omega e power minus j omega t d omega. So this is not a correct. Minus j omega, it's not a correct. The second one is a correct. X of t equal to 1 by 2 pi integration over minus infinity to infinity x of j omega e power j omega t d omega. We have to integrate with respect to omega. Okay, the x of j omega into e power j omega t plus j omega t. This is called as a synthesis equation. Synthesis means it's a inverse Fourier transform equation. Analysis means Fourier transform equation. Okay, the third question, the Fourier transform of impulse signal is. Okay, so you just remember some standard signal, you just remember the Fourier transform answer. So the Fourier transform of impulse signal del of t. Okay. So using this Fourier transform formula, if you are calculating the Fourier transform of impulse signal means the answer is 1. Okay. So for any transform, if you are taking any transform for the impulse signal, the answer it should be 1. Okay. Then the next one, the Fourier transform of unit step signal u of ts. So u of t, if you want to learn how to calculate the Fourier transform of this unit signal, so I will give a link in the description box of that video. So you go and search that. Okay, so if you are calculating Fourier transform of unit step signal, we will get the answer is 1 by j omega plus pi into del of omega. Okay, this is the answer. This is the correct answer for unit step signal. Okay. So here, so that is the how to calculate this unit step signal I given. So you see the u of t, the unit step signal u of t, it can be written as 1 by 2 plus 1 by 2 signum of t. Okay. So 1 by 2 means it's a DC signal plus 1 by 2 signum of t. So this is the relation. In the first video, one question is there in the standard signal, what is the relation between unit step and signum signal? This is the relation. So using the signal, we are going to calculate. So if you are taking Fourier transform on both sides of this equation, so the Fourier transform of u of t equal to Fourier transform of the constant 1 by 2 plus Fourier transform of 1 by 2 signum of t. So you know the Fourier transform of the DC signal of amplitude 1 by 2 is pi into del of omega. Okay, and the Fourier transform of the signum of t is 2 by j omega. So here 1 by 2 is there. So 1 by 2 into 2 by j omega, the answer is 1 by j omega. So that's why the Fourier transform of this combined 1 by 2 plus 1 by 2 signum of t is pi into del of omega plus 1 by j omega. Okay, so this is the answer. So you just remember it. For del of t, the answer is 1. For u of t, the answer is 1 by j omega plus pi into del of omega. Okay, then the next one, the Fourier transform of exponential signal x of t equal to e power minus at u of t for a greater than 0s. Okay, so these are all the standard signals. So the answer you should remember. What is the Fourier transform of the exponentially decaying signal e power minus at u of t is 1 divided by a plus j omega. Okay, 1 by a plus j omega is the correct answer. Then find the Fourier transform of the rising exponential signal e power at u of minus t. So this signal e power minus at u of t is the exponentially decaying signal, and this signal is available for the positive time axis. Okay, this is the causal signal. So for the signal, the Fourier transform is 1 by a plus j omega. If it is a minus a means here 1 plus a plus j omega. Here you see e power at u of minus t. So e power at u of minus t means it's exponentially rising signal, but the signal is available for the negative time duration. Okay, so this signal is having the Fourier transform answer is that 1 divided by a minus j omega. Okay, so you just remember it. E power at u of minus t, the Fourier transform is 1 by a minus j omega. Okay, then find the Fourier transform of the function x of t equal to e power minus a modulus t. Okay, so this is the double-sided exponential signal. Okay, so you know this is the double-sided exponential signal e power minus a modulus t. So already we solved this problem is a separate problem in the video. So I will give the link for that video in the description box. You go and search. So this e power minus a modulus t, it can be splitted as e power minus at u of t plus e power at u of minus t. That is the addition of these two problem. Okay, the e power minus a modulus t problem, it is nothing but this signal plus this signal. Addition of these two signal, it is said to be the e power minus a modulus t. So that's why the Fourier transform answer is that this 1 divided by a plus j omega plus 1 by a minus j omega. So if you are adding these two answer and if you are taking the LCM means we will get the answer is 2a divided by a squared plus omega squared. Okay, so these are all the standard answer. If we want to learn how to calculate this answer in a detailed manner means I will give link for these problems. Okay, all problem del of t, exponential signal, double-sided exponential signal, sine omega t, cos omega t for all problem. I will give the link in the description box. You can go and you can learn. Okay. So the answer is, you just remember it, 2a by a squared plus omega squared. And the next question, which one is a gate function? Okay, so already one question in the first standard signal, gate function. So gate function, it is nothing but it is the other name of rectangular pulse. Okay, so the rectangular pulse, it is otherwise called as gate function. So you know the rectangular pulse, it is having the constant amplitude for the some time duration minus t by 2 to t by 2. Or some minus tau by 2 to tau by 2. Okay, this function is called as gate function. So you see x of t equal to 1 for modulus of t less than tau divided by 2. Yes, it is correct. 0 elsewhere. Then x of t equal to 1 for modulus of t greater than tau by 2. Modulus of t greater than tau by 2 means this above tau by 2. Okay, so you see that is less than modulus t less than tau by 2 means minus tau by 2 to tau by 2. The answer is 1. Okay, this is the first one is the correct thing. And the second means that is the opposite version of the signal. It is the second one. It's wrong. X of t equal to 1 for 0 to tau by 2. So only this duration is available. Okay, that is not a gate function. Gate function means for it's a symmetric minus tau by 2 to tau by 2. The amplitude is 1. It's called as a gate function. Okay. Then find the Fourier transform of rectangular pulse of amplitude A and with this t. Okay, so this one we have to find the Fourier transform of rectangular pulse of amplitude A. This constant amplitude A and this width is said to be capital T. Okay, so capital T means this lower limit is capital T by 2. This upper limit is plus T by 2. So what is the Fourier transform of this rectangular pulse? So already you know the rectangular pulse and the sync pulse is a Fourier transform pair. Okay, that is if you are taking transform for rectangular pulse, we will get the answer is a sinc pulse. Okay, sinc pulse, the center area, that is this is called as a sinc pulse. Okay, so the answer for this rectangular pulse is AT sinc FT. Okay, this is the answer. Okay, so if you want to how to calculate this answer means, so I will give link in the description box for this problem. You go and search. So the answer is AT sinc FT. Okay, you just remember it is if amplitude A and width is T means the answer is A into T sinc FT. Okay, this is the one. The next one, which of the following is not a Fourier transform pair? Okay, that is del of T. If you are taking Fourier transform for unit impulse signal means the answer is 1. This is the correct. Okay, this is not, this is the correct one. A rect of T by T, if you are taking Fourier transform, AT sinc FT. Okay, so you see this question, if you are taking rectangular pulse Fourier transform, we will get the answer as sinc. This is also correct. Okay, then U of T, unit step signal, if you are taking Fourier transform, the answer is 1 by j omega plus pi into del of omega. Yes, it is also a correct. Then e power at u of minus t, the answer is 1 by a plus j omega. So it is not a correct. E power at u of minus t means the answer is 1 by a minus j omega. So this is the wrong answer. Remaining 3 is the correct answers. Okay. Then the next question, which one signal is a Fourier transform pair for sinc pulse? Okay, so already I told in this question, if you are taking Fourier transform for rectangular pulse, the answer is sinc. Similarly, if you are taking Fourier transform for sinc signal, we will get the shape is rectangular. That's why the rectangular pulse and sinc pulse is a Fourier transform pair. Okay. So which one is a Fourier transform pair for sinc pulse? Sine, rectangular pulse, signum, none of the above. Rectangular pulse. This is the correct answer. Okay. Next question. Find the Fourier transform of the function x of t equal to cos omega naught t into u of t. So what is the signal cos omega naught t into u of t? It's a cosine signal. Okay. It's a cosine waveform of frequency omega naught. Okay. The signal is multiplied with u of t. So the signal is only available for the positive time duration. So what is the Fourier transform of this cos omega naught t u of t means? This is the answer. That is minus j omega divided by omega squared minus omega naught squared. Or otherwise j omega by omega naught squared minus omega squared. This minus you will give it to this means we will get the answer. Okay, this is the cos omega naught t. Find the Fourier transform of sine omega naught t. So the sine omega naught t answer is minus omega naught by omega squared minus omega naught squared. So here for sine omega naught and cos omega naught, you see the denominator, it should be same, omega squared minus omega naught squared. Here also omega squared minus omega naught squared. If it is a cos omega naught, the numerator is minus j omega. For sine omega naught, the numerator is minus omega naught. Okay, so these are the standard answers you should remember. Then find the Fourier transform of signum function. So the Fourier transform of the signum function answer is 2 by j omega. Okay, so 2 by j omega. This is the answer for the Fourier transform. Okay, then find the Fourier transform of the function t into e power at e power minus at u of t. So already you know e power minus at u of t, the answer is 1 by a plus j omega. If you are multiplying this function with t means, so for this signal, the answer, the Fourier transform answer is 1 by a plus j omega the whole squared. Okay, this is the Fourier transform answer for t into e power minus at u of t. Okay, then the next one, the Fourier transform of function x of t is x of j omega. Then what will be the Fourier transform of dx of t divided by dt? So this one, this is the differentiation property. If one signal x of t, the Fourier transform is x of j omega means what will be the Fourier transform of dx of t divided by dt? So the differentiation of the particular signal it gives, so according to the differentiation property, so the answer is that the j omega multiplied, x of j omega multiplied with j omega. Okay, this is the differentiation property. According to the differentiation property, so you see, according to the differentiation property of Fourier transform, d by dt of x of t, the Fourier transform is j2 pi f into x of f. So this 2 pi f we can written as omega. So j omega into x of j omega. Okay, this is the differentiation property. Then the next one, find the inverse Fourier transform of 1. Okay, so 1 is the, so already you know, the inverse, that is del of t is having del of t. If you are taking del of t Fourier transform, we will get the answer is 1. So for 1, if you are taking the inverse, means we will get the answer is del of t. Okay, so del of t 1 is the Fourier transform pair. Then find the inverse Fourier transform of signum of omega. Okay, the signum of omega is having the inverse Fourier transform answer is that j divided by pi t. Okay, this is the answer. Then the inverse Fourier transform of del of omega. So what is the inverse Fourier transform of del of omega? The del of omega, the inverse Fourier transform is 1. Okay, the inverse Fourier transform is 1. Then the next question, for Parseval theorem for energy tells that. Okay, so what is Parseval theorem? If you want to find this Parseval theorem, it gives the energy value in terms of the Fourier transform of its particular signal. Okay, it gives the relation between energy in terms of Fourier transform value. Okay, so which one is means E equal to minus infinity to infinity g of t the squared into dt. This is not a Parseval theorem. This is the energy formula in time domain. Okay, E equal to integration minus infinity to infinity g of f the whole squared into df. Okay, this is the correct. Where g of f is said to be the Fourier transform of the particular signal g of t. Okay, so this one is the correct one. Energy in terms of the Fourier transform answer is said to be Parseval theorem. This is the first one is also energy equation is correct, but this is not a Parseval theorem. Parseval theorem means it gives the energy in terms of Fourier transform. So this one is a correct. And the next question you see, if f1 of t is having the Fourier transform capital F1 of j omega, the second signal f2 of t is having the Fourier transform f2 of j omega, then f1 of t into f2 of t is, if you are multiplying these two signal means, what is the Fourier transform of this f1 of t, f2 of t means the answer is that 1 divided by 2 pi f1 of j omega convolution with f2 of j omega. So as per the convolution in frequency domain property, if you are taking multiplication in time domain means that is transformed into, okay, so the Fourier transform of this one, it gives the answer is that the convolution of the individual signal divided by the 2 pi. Okay, it is the answer. If you are multiplying the two signal in time domain means the Fourier transform answer for that signal is that convolution between the individual Fourier transform and divided by 2 pi. Then the next question you see, d power n divided by dt power n of f of t. Okay, equal to, that is the Fourier transform of, okay, Fourier transform of d power n divided by dt power n of f of t is j omega to the power n into f of j omega. This is true or false? True only. Okay, so according to the differentiation property, if you are differentiating the signal one time, and if you are taking the Fourier transform, the answer is that j omega into f of j omega. So n time if you are differentiating, we will get j omega to the power n into f of j omega. So it's a true. Okay, Fourier transform of this one is correct. Then the next one, a signal m of t is multiplied by a sinusoidal waveform of frequency fc such that v of t equal to m of t cos 2 pi fct. If the Fourier transform of m of t is capital M of f, then what is the Fourier transform of v of t? Okay, that is here one message signal m of t is multiplied with one cosine signal. Okay, so this is called as the modulation theorem. In the process, in the communication, modulation, it plays a very important role. if you are if you are mixing one message signal with one high frequency carrier signal means, so what is the Fourier transform of this modulated signal? That is the question. So according to the modulation theorem, okay, so we will get two spectrum. One spectrum is shifted to the left side and one spectrum is shifted to the right side by the amount Fc. Okay, so the answer is 0.5 m of F plus Fc plus 0.5 m of F minus Fc. This is the answer. Okay, so in the first one, 0.5, that is 0.5 means 1 by 2. 1 by 2 m of F plus Fc. Only the spectrum is shifted to left side. This is only the spectrum is shifted to right side. But if you are multiplying any signal with the cos 2 pi fct, and if you are taking the Fourier transform means according to the multiplication, that is modulation property, the answer is that the spectrum is shifted to two side. One is left side by the amount Fc, one is right side by the amount Fc, and the amplitude is half. Okay, this is the answer. 1 by 2 m of F plus Fc plus 1 by 2 m of F minus Fc. This is the thing. Okay, this is called as modulation process. And next one, a signal defined by the equation f of t equal to 0 for t less than 0. F of t equal to E for t between 0 to A, and f of t equal to 0 for t greater than A. This is called as which one? Okay, it's a step function, pulse function, a shifted step function originating at t equal to A, none of the above. So what they are telling, f of t equal to E for the time 0 to A. Okay, for the time t is from 0 to A, the amplitude is E. For t less than 0, 0. For t greater than A, 0. So this signal is called as, this is a step function? No. This is a pulse function? Yes. This is the shifted step function? No. None of the above. So this is the pulse. Okay, this is the rectangular pulse shifted by some amount. Okay, pulse. This is called as a pulse signal of certain width. The signal is available. This is the pulse. Okay, then what is the Fourier transform of integration of x of tau into d tau? So according to the integration property. Okay, so you already we discussed the differentiation property. If you are taking differentiation of that particular signal, that is the Fourier transform of dx of t divided by dt is j omega multiplied with x of j omega. Similarly, if you are integrating that x of t, if you are taking the Fourier transform means, the answer is that we have to divide the j omega. Okay, that is x of j omega divided by j omega. Differentiation means j omega into x of j omega. Integration means x of j omega by j omega. Okay, so according to the integration property, this is the one. Okay, so you see, according to the integration property, if you are taking differentiation, we have to multiply j omega with x of f. If you are integrating 1 by j omega into x of f. Okay, this is the integration property of Fourier transform. Then the next question, area under x of t is equal to its Fourier transform at f equal to 0. Okay, this is the true or false. So what's the thing? The area under any signal x of t is equal to its Fourier transform at f equal to 0. This is the true only. Okay, so according to the area under x of t, there is a property, the two properties there in Fourier transform, area under x of t and area under x of f. The area under x of t, that is integration minus infinity to infinity x of t dt. The answer is that capital X of 0. What is the meaning? Area under any signal x of t, it gives the Fourier transform answer at f is equal to 0. Similarly, the area under x of f is there. If we want to find area under x of f means the answer is equal to the small x of t at a time t equal to 0. Okay, so according to this area under x of t property, this one is that. Area under x of t is equal to its Fourier transform at f equal to 0. Yes, true. Okay, then what is the Fourier transform of x of t minus t naught? What is x of t minus t naught? It's a time delayed signal. Okay, so according to the time shifting property of Fourier transform, this is the time shifting property. If we want to find Fourier transform of the time shifted signal means the answer is that the x of f or x of j omega multiplied with e power minus j 2 pi f t naught, where t naught is the amount of delay. Instead of this 2 pi f, you may put omega also. Okay, so according to that one, x of t is having the Fourier transform as x of j omega. So x of t minus t naught, the Fourier transform is x of j omega multiplied with e power minus j omega t naught. Okay, this is the correct answer. If x of t plus t naught means the Fourier transform answer is that x of j omega into e power j omega t naught. Okay, so for this problem, this is the thing. And next question, what is the Fourier transform of x1 of t convolution with x2 of t? Asterisk. The asterisk indicates convolution. So if you are taking convolution in time domain means, and what is the Fourier transform of this convolution of this two signal means, according to the convolution property, if you are taking convolution in time domain means it gets transformed into multiplication in Fourier domain. So the answer is that x1 of j omega into x2 of j omega. If you are taking convolution in time domain, and if you are taking Fourier transform, the answer is that multiplication of x1 of j omega into x2 of j omega. Then find the Fourier transform of del of t minus 1. Okay, so already you know the Fourier transform of del of t is 1. Okay, now we have to find the Fourier transform of del of t minus 1. What is del of t minus 1? Using shifting property, time shifting property, we have to solve. So according to the time shifting property, x of t minus t naught, the Fourier transform is e power minus j2 pi f t naught into x of f. So now x of f value, you know, 1. Okay, so del of t minus 1 is having the Fourier transform is that the del of t Fourier transform is 1 multiplied with e power minus j2 pi f into t naught. What is the t naught value? 1. So this 2 pi f we can written as omega. So the answer is e power minus j omega. So according to the shifting property, e power minus j omega. Similarly, if you are asking Fourier transform of del of t plus 1 means the answer is e power j omega. Okay, then the next question, what is the Fourier transform of unit ramp signal? Okay, so you know the Fourier transform is not applicable for all signals. Okay, so Fourier transform can be used if it satisfy the condition is that if the signal is absolutely integrable only, we can apply the Fourier transform. But the ramp signal R of t, you know, R of t is exponentially, the amplitude of the ramp signal is exponentially growing. Okay, so for this signal, the Fourier transform does not exist. Okay, so these are all the not at all answers. For Fourier transform of unit ramp, we can't find the Fourier transform of unit ramp signal since it's an infinite growing signal. Okay, so the Fourier transform does not exist for this ramp signal and exponentially rising e power at u of t. So for that problem, Fourier transform is not applicable. So does not exist. This is the answer. Okay. So these are all the some of the questions from the Fourier transform part. Okay. So if you want to learn more about this problem solving means and this property, so I will give link in the description box for all properties of Fourier transform as well as the problems. So you go and learn. Okay, so thanks for watching my channel and please subscribe my channel for more videos in the next video. So we will see about the MCQ questions from the part, the third part of the second unit, Laplace transform. Okay, thank you.